Philip Domingo, and I'm going to be talking about chatbots. So I'm going to be talking about Microsoft Bot Framework on how you can use this framework to build an intelligent bot to make your development a lot faster and perhaps a lot better. But before I do start with all the new stuff, talking about this framework, talking about, giving you a live demo, first thing I want to talk about is why. Like, why would you want to use a framework in the first place, right? Because, like, imagine a world without any bot framework. If you're a developer, you want to build a chatbot, and typically this is how you're going to do it. Mainly, you're going to focus on two things. Number one, which is pretty given, is when you build a chatbot, of course, you're going to build a chatbot in where it has a lot of features. A lot of features in where, of course, it's going to be usable for your users, it's going to be intuitive and all those sort of stuff. Point is, not just a chatbot, right? Whenever you build a software, maybe a website or a mobile app, of course, you're going to build it with tons of features. In this case, it's a chatbot, you're going to do all sort of AI stuff. But that's number one. Okay, so pretty given, pretty straightforward. But number two is where most of the time, or big problems comes in. As a developer, this is where it consumes a lot of time. Again, without using any bot framework at all. Because in number two, say that you're already developing a chatbot, you already have tons of features, right? And then number two, what you want to do is you now want to publish it into the market. You want users to actually use it. Yes? So now, the problem here is that when you do that, you would want to bring your chatbot into as much channels as much as possible. When I say channels, these are Facebook Messenger, these are Slack, these are all those sort of things. Because the problem here, let's say you're doing this from scratch, is that you have to make sure, because you have to keep in mind that when you're using all of these different channels, Facebook Messenger, Skype, Slack, Telegram, Viber, all those sort of things, all these channels have their own sets of API, have their own sets of SDK. So the thing here, as a developer, when you're building this, of course you have to understand each and every one of those channels, or rather all of those APIs. And the thing here, so that's number one problem in the number two. And another problem there is that the problem 2.2 is that when you're building now, let's say you're integrating it into Facebook Messenger, integrating it into Skype, all those sort of things. Now the problem is you have to make sure that what works in Facebook Messenger will work in other channels as well. Do you agree? Right? So that's the main problem. And and I've been working with a lot of enterprise and public sector customers, and I've seen this happen. I would meet a customer, especially in enterprise, that they've developed a chatbot beforehand, before meeting them. They already have a chatbot and it's already available in Facebook. And it works really great. I've tried it myself, it works really fine, it's usable. And I was asking them, and as I was talking to them, they were telling me that, what? Our plan here with our chatbot is not just to bring it into Facebook. We want to bring this on other channels as well. We want to bring this in Telegram, we want to bring this in Skype, maybe someday in SMS, in email as well. And okay, so that's great, because of course you would want to bring your chatbot in as much channels as possible, right? But my next question is, okay, how are you going to do that? And they would say, well, we have a partner who would do that for us, who would code that for us. So but there's no problem on their end. They already have a partner who did that chatbot and just going to do it again on those additional requirements. But my last question to them is, okay, how long is it going to take? Let's say, okay, now you have Facebook Messenger, and then you want to bring it to Skype and to Viber as well. How long is it going to take? They would say, for one channel, I would say at least 1 month. Because, I would have to make sure they would still have to understand APIs, they would have to understand SDK, the developers, and then they have to make sure that, again, what works on Facebook would still work the same way in Viber, Telegram, and other channels. So that's the main problem when you're going to do it from scratch. And so this is where Microsoft Bot Framework comes in. So Microsoft Bot Framework is a framework that you would use to build intelligent bots. And the main thing here is that you code once. Take note, as a developer, you code once and then you can already bring your chatbot into many channels without writing additional code. Do take note of that. But Microsoft Bot Framework is divided into a few things. There's three here. There's Microsoft, there's Bot Builder SDK. So let me just zoom this in. So yeah, there you go. So first one is there's Bot Builder SDK. So this Bot Builder SDK is what you, the developer, will be using. Okay? So this Bot Builder SDK is take note, this is open source. If if you search it with, if you Google it with Bing, you would see Bot Builder SDK. So you will see this, and what's really cool about this is that one of the things I would want to emphasize is that recently, just last September 2018, Microsoft announced a new version of the bot framework. It's now version 4. But before, how the only language it supports, so you are the developer, before version 4, the only language it supports is C Sharp, which is C Sharp.NET Framework, not .NET Core, which is kind of sad because before I would develop a software, and I'm not just using Windows, I'm using Mac, I'm using Linux as well. So it was hard for me to use that. Though I was using it because I've been using Windows for a while now. But the problem there is that it's C Sharp, yet it's just .NET Framework, even though there was already a .NET Core during that time. And second is it's Node.js. So Node.js, that's what I've been really using since it's cross-platform. But in the recent announcement, the version 4, they've now announced additional support. So number one is the C Sharp. It's now using .NET Core. So no more .NET Framework, it's now .NET Core, it's cross-platform. You can use it in Linux, you can use it in Mac. There's Node.js as well. Node.js, important to take note that there's now a better support in TypeScript, which is really cool that you're using that, but I'm not using that yet. So, and then lastly is the Java and Python, which is still in preview. It's still preview, but it's getting there. And seeing this is really important because I would meet customers. They still have this perspective with Microsoft that if you're using Microsoft, you have to use everything Microsoft. That's still the thinking. Maybe that's how it works before they got here. But now it's not. I've been working with customers and we're not using any Microsoft programming language at all. We're using Python. And in fact, personally, I'm really excited to use the Python version because I would do machine learning and using that language, and I would love to use the same thing in this framework. So that's number one, the Bot Builder SDK. And then you can bring it into multiple channels. So I will show that as well later on. So next thing I would want to share with you is that one of the most important things that you need to understand when you're using this framework is that, like I mentioned, you're going to build a chatbot, and pretty much most of the time you're going to use AI. But it's important to understand that Microsoft Bot Framework is still just a framework. About framework. Meaning to say, let's say, most of the time when we would build a chatbot, we would want this chatbot to be able to understand users naturally. Sometimes we would want these users to recognize an individual. We would want the chatbot to understand an object and things like that, sentiment analysis, and all those sort of AI services. Out of the box, important note, out of the box, it does not provide it to you. Chatbot, basically, bot framework, it allows you to build bots a lot faster, but when it comes to AI services, you have to use a different set of AI services. So in Microsoft, in Azure, there's what we call as cognitive service. So cognitive service are pre-built AI services. So the thing here is that even if you're not a data scientist, even if you don't understand machine learning or you have little knowledge of machine learning, you can already use this AI service that you can integrate your chatbot to make it a lot smarter. But I'm not going to focus so much on this one because the next topic after me will be focusing about cognitive service. Okay, so stay tuned on that one. But the point here, what I'm trying to show here is that this is the type of AI services that you will typically use in a bot framework. So so next one is this. So what I'm trying to show you now is the overall, at least the overview solution of how you would use Microsoft Bot Framework. So let me break this down. So number one is the user input. So the idea here is that you can have a user. You can have this user input whether it's text message, it can be voice, or it can be image. Okay, and then from there, so whatever it is that your user are using, maybe again text, speech, or image attachments, you can then use it in different channels. So you'll see here that there's Cortana, there's Facebook, there's Skype, there's Slack, and all those sort of things. And then this is where Microsoft Bot Framework comes in. So you'll see this little cute brain. That this is the Microsoft Bot Framework. This is your bot framework. This is your chatbot. And then from here, you will see that it's integrating the different AI services. So that's how it works. That's how you build your chatbot using Microsoft technologies. And then from here, since I think I forgot to mention that Microsoft Bot Framework is a code first, okay? Code first framework. So if you're a developer and you're really passionate about writing code, doing all those things, it could be an advantage of using this. And then since I mentioned that, because typically chatbot works kind of like an API, right? So you would write your code that way, and then of course if you would want to use your Dynamic Business Applications, so you have an API on your on-premise, you want your chatbot to connect to your database and all those sort of things from your different cloud providers or your own data centers. Of course, it is also possible in Azure or in other cloud or on-premise. Again, so that's the overview of Microsoft Bot Framework, at least the solution overview. So in summary, how Microsoft Bot Framework is an open source, bot framework. It has all this SLA, it's multilingual as well, so it supports multiple language, but unfortunately there's no support for Tagalog yet. It's multiple channels, it's integrated with your IoT devices, and then it's conversational, of course. So that's the summary of Microsoft Bot Framework. Okay, at least high-level summary. Next thing I want to do is I want to go into details. Because we're developers here, at least most of us, or some of us, I don't know. We're developers, and the next thing we would want to understand is the development life cycle. So of course, as a developer, we have this development life cycle of a bot, right? And we would start from planning to building to testing until evaluating. So what I want to show here is that how you can use the tools within Microsoft Bot Framework across all these stages. So first thing, of course, we're going to start with planning. So planning, we have this tool we call as ChatDAO. ChatDAO, I'll do a live demo, but just to share with you in terms of prerequisite, this is what you're going to need. You're going to need a bot framework emulator. Of course, this is where we're going to test our chatbot locally. And then a Node.js. Node.js, you have to install that at least version 5. And then you can install this in this Node package of ChatDAO. So this is where my slides would end. Everything else will be like the most. I hope you're excited. So now, what I'm going to do is, I'm going to show you how to use ChatDAO, at least in the planning stage. So what we're going to do here is you can use any text editor that you're using, maybe Notepad, maybe Code, maybe Sublime, whatever. So what I'm going to do here is I'm just going to use Notepad. And what I'm going to do here, by the way, important, this is not part of my talk, but I just want to share this because this is pretty cool. I'm using Notepad, but you see here that it's not just Notepad, it's Notepad 2. So Notepad is actually an open source project that replaces your original Notepad. And what's really cool about this is it has this transparent thing. You see that? So I'm watching a YouTube video or I'm taking down notes, and then I have this Notepad that can do this transparent stuff, which is really cool, right? So now, what I'm going to do is I'm going to use ChatDAO. So the way you're going to do it, because in the planning stage, this is where you do prototyping. Yes? So now, of course, we do prototyping. So typically, what you would want to do is you're gonna explore because you're talking about chatbot. And the way you're gonna design chatbot is instead of building pages just like in website or mobile app, we're now designing conversation. And that's what we're gonna do. So how we're gonna do it in ChatDAO is like this. So you type user, who's your user? Who's the example? Who's the example? Who's the persona here? So let's say the user is named Ed. Or maybe not. I'm going to just use that. Because I've seen on Facebook, a lot of people are already having that with it. So that's the user, and then we have a bot name. Let's say future now. And then from here, let's say this is now where we're going to do it. So you're going to say, okay, as a user, what is so because the way you're going to design this is per conversation. You have your conversation for introduction, you have your conversation for inquiry, you have all these sorts of things. So now let's say I'm going to build a conversation for introduction or greetings. Like, for example, Dan said hi, and then how do you visualize your bot will respond? Let's just say, hey, what can I do for you? And that's it. You do that, you type that, and then you press save. And then you go to desktop, whatever you have to put here, so I'm just going to say greetings. Important that your file name will be .chat, okay? So .chat, and then you save that. So now that you have that .chat file, next thing you're going to do is we're going to use ChatDAO, okay? Because the idea here is basically we just created a text file that is using chat file. And then what we want to do next is open your command line. We're going to use the ChatDAO. I'm going to go to my desktop. And then we have the release tool. And then what I'm gonna do is using the chat down command that I just uploaded using the load, chat down the file name, release tool, chat, and then I want to convert it into transfer. So now what we're doing is we're now converting that chat file into a transcript file. Because this transcript file is the type of file that the emulator will be able to understand. Because just the text file, the chat file, the emulator doesn't understand that. So we need to chat down for the emulator, our bot frame emulator I mentioned earlier, to be able to understand what we just typed and the chat file. Okay? So now it's saying that it's not existing. Okay. Spelling. Okay, yeah. Thank you. Yeah, this is called, you would hear about, what do you call that? Spooling. But this is like mob programming, because I have all of you assisting me in my code. So, yeah, okay, so successful. Thank you so much for that one. Now, we already have our, so if we look at this, we already have our release tool that transcript, right? So, what I'm going to do next is I'm going to open up the emulator. So, this is how the bot frame emulator looks like. And next thing I would want to do is go to this, go to file, and then click open transcript. Now, from here, I would want to go to my desktop, what we just did, and then release tool. So I'm now loading the transcript file. And then from here, you're going to see that it is as if it's already running as a chatbot. So that's one. But of course, important to understand that in chatbot, it's not just about text, right? There's this UI elements called cards that you can also use during this prototyping. Because how it looks like, so I'm not going to do it from scratch. I already have a código here, which this is how it looks like. So remember earlier what I just did. I had a user, and then the bot name, and then what the user is asking that we're going to register for the conference. And then the bot is going to reply, hey, you can check it in the registration link below. And then you'll notice this syntax. So in bot framework, there's different set of bars. There's hero bar, there's carousel, and all those sort of things. So you can search for it online, but I'm not going to go into detail because I don't really have so much time here. But the point here is that there's the syntax for me to use card during the prototyping. So what I'm going to do next is to show it to you how it will actually look like. So I'm going to open the transcript, go back to the file path, and then demo, transcript, and then from here, you will see that it's supposed to look visual. Yeah. So you can also do this, do all these things using chat-down. So this is how you can use chat-down on the planning stage. And for me, this is very important. Typically, I would work with customers, and you would work with non-technical people, right? You would talk with the stakeholders, you would talk with project managers, product owners, business users, and they don't understand the code, of course. And can you just imagine if you're going to do this, and every time you do this, you're writing the code, and then every time you present it to them, they're going to say, I think it's much better to do this. There's a lot of change of mind, right? Especially in some of our clients, really something really what I don't know. So the point is, when you using this, the effort is really low because you're just typing as if you're typing, writing a story. So that's chat-down. The next thing I would want to do is now, what I showed you earlier is this, right? It's this. So I showed you the planning part. Now we're gonna go into this entire build to evaluate thing. So this is where Azure comes in. Though keep in mind that there's a lot of ways to do this. For the sake of this demo, to make it simple, I'm going to do it in Azure. But again, you can do it, in your local machine if you're really that geeky, you want to do everything in CLI, you're that cool, you can do that as well. For now, I'm going to go to Azure. So, what you can do here, I don't have any internet. What is that? So, okay, hotspot, I'm using my OnePlus, so don't connect here. Connecting. Sorry for the commercial. So, okay, so while waiting for me to connect to the Wi-Fi, important thing, okay, next thing you have to do is you now have to go to Azure. So, how you're going to go to Azure is open up any browser that you're using, and yes, it's okay to not use Edge, it's okay to not use our browser, you can use Firefox, like in Linux, I'm using Firefox here in front of you, right? You can use Chrome as well, it's up to you if you want to use IE, okay? But for here, I'm going to use, I open up the browser and then went to the portal. So How are you going to do it? Is portal.azure.com. While waiting, so important to note that there's a free trial of Azure. So there's a 1 year, 12 months free trial of Azure. So, but you just have to have a credit card, but we're not going to give you. So it's okay. So waiting. Let's start again in our browser. Okay, so it's loading now. Okay, loading. Maybe you want to here. So first thing you're gonna do is this is the portal, this is a dashboard, this is like your homepage in Azure. Okay, what we're gonna do now is we're gonna do the chatbot within Azure, and how we're gonna do that is go to create a resource from here. Create a resource. Okay. Two things. You can either search for it or you can go to AI plus machine learning. So from here, you will notice a lot of services. There's the cognitive service I mentioned. We also have a data science virtual machine. It's a virtual machine that already contains everything or almost everything that you will need for data science. But that's not part of my talk. In our case, we're going to settle with the web app bot. So for now, we go with the web app bot. Okay, click this one. Okay, so before I proceed, one of the things, I just wanted to share this with you. One of my dilemma in preparing this demo is, should I still go with the simple stuff? Because the reason why this is my dilemma is because, if you would search online, how to get started with Microsoft Cloud Framework, there's already a lot of YouTube videos, there's already a lot of blogs, there's already a lot of tutorials, even if you go to community events, there's a similar demo of how you're going to do this. So my dilemma is, am I still supposed to show it to you? In fact, I only have 25 minutes to do this. But then I have a dilemma is maybe, just maybe, most of you, or maybe all of you, doesn't have any idea about this. So what I decided is still, I'm going to do this, I'm going to do this demo, but I'm going to do it really quick. Because again, if you want to learn more about this, we have documentation, how to do it online. There's already a lot of it. What I wanted to focus on is on the last part where it's really new. It's part of the September 2018 release. And that's where I want to focus on because pretty much there, you won't find a lot of content online. Okay, so how I'm going to do this is from here, I click the web app bot. Now you have to fill in the form. So here, you're going to need your chat bot. Let's say feature now. So your Azure subscription, and then your research group. So research group is kind of like the container for different sets of services. So I have a connection error. Okay, so I don't have anything for the series. Okay, so wait a minute. So I don't know why. Okay, so let's do this really quick because maybe the demo, whoever that is not. Okay, so let's do this again, really quick, but don't worry, I have one. Okay, let's just do this really quick. I have to pause this. Oh, I forgot to pause this. Okay, maybe I'm just here and go. More now than ever. Okay, so I don't know how much time is, how many minutes do we still have? Okay, so just wait, so it's going to be time. So, I don't know what I'm supposed to say. Okay, again, going back, so what happened? Feature now, what? When you use Gen1 spelling, no one uses it. See? You will see later that no one uses this name. Okay, so and then the resource groups like containers for different sets of services. So it could be grouped by project, it could be grouped by department, whatever. In this case, feature now, demo. And after that, this is really simple. So, okay, so this is, okay, I'm not going to fill up all this because I already have this here. Okay, but what's important to show here is this bot template. So right now, we have this bot template and you can see that there's this SDK version. There's for version 3 and then for version 4. I do suggest when you still don't have any deal with Microsoft Confident, but you want to get started with it, don't settle with the lower version. Start with the version 4. Start with the latest news. Moving on, that's going to be that's what will have more support. And then from here, you can either choose whatever language you're using. So in this case, you would only choose C# and Node.js because I mentioned earlier, right? I said that there's Java, there's Python as well, but we're not seeing it here. The reason for that is still preview. Okay, and then from here, you will see a couple of a couple of templates, but in SDK version 3, there's a whole lot more. But since version 2 is a bit new, it's still a bit few compared to version 3. For now, if you're starting with Microsoft Bot Framework, do start with the basic stuff. I do suggest start with the EchoBot. The reason for this is because I want you to learn one thing at a time. Because earlier you mentioned, and now I'm talking about Microsoft Bot Framework. Earlier I mentioned about AI services, cognitive services, and now I'm showing you Azure. So there's a whole lot of things that you have to understand. But I do suggest when you're learning new things, especially new technology, one thing at a time. Okay? So from here, you fill up all these forms, but again, as I mentioned, I already have this created. So what you do here, fill up all this, and then press create, which I'm not going to do anymore because I don't have a lot of time. Now what I'm going to do is, once you're done creating that, this is how it's going to look like. This is my demo. So this is the set of services that it will have. So it contains this is the bot service. Remember my slide, my second slide, third slide, I shared you the Azure bot service. This is that Azure bot service, this one. And then there's this app service. This is basically your VM, kind of like VM, but in a platform as a service. And then your storage for the store the conversation between your bot and your user, and then application insights. This is very important. I will show you later on that the new template is included. For now, once you're done provisioning it will take around 2 minutes to do that. And then, from here, you can do a couple of things. So you see that there's this build, testing web chat, analytics, and channels. So first thing is, let's start with building, right? Because, planning, building, testing. From the build, you can have some options here. So first is, it will give you the links on how you can download your source code. Number one, where you can download the editor. Number two, where you use the CLI tools. But I'm not going to focus so much on the CLI tools. There's a whole lot more, which is very new for now. Just focus on this one. But you also have that option to just do the code change online. So I click this. It's going to open up the vicious which is called online. Sometimes anymore. But I do suggest you don't do this in your actual development. You just do this if you want to play around, you want to understand how bot framework works, you want to, tinker a little bit of code. But the other reason why I don't suggest using this is because if you're going to look at it, the whole DLL is here, which is a bit messy, right? As a developer, you don't want to look at this, right? You don't want to mess it up. But the point here is that, it contains the source code. So, for example, here's the code. So you can just take a look at this offline. There's a whole lot of documentation, but I'm not going to focus on too much details a lot. Again, because I said I'm going to be quick here because there's already a lot of contents available in this online. So now you can edit that, you can do whatever you want, and then once you're done editing, you can have that test. So you can either test it offline using the emulator I just showed you here, or do it online using the web chat. From here, we have that here. So in the next event, what's happening, at least it's not more than debugging, and then say here. So the reason why it's a fact that, it's just a quick fact that, the reason why it's called EchoBot is because everything you say, it will echo back to you. That's what you see here, it's a hey, and then you say hi, say hi. So that's the part. Next thing, because here in my slide, I mentioned, okay, we now build it, at least we're using the default template, and then now we're testing it. Next thing we want to do is publish it, though it's already published here since it's already in Azure. Next thing we want to do is to connect it, meaning to say connect it to different channels. Because remember earlier I shared with you the main purpose of this framework is to use one code. I have 10 minutes left. Use one code and then publish it everywhere. Right? And that's what I'm going to show you. So here, in the channels part, you will see that there's already a lot of channels that you can pretty much pick. So here by default, it's already available in Skype and web chat. So web chat is, you want to use an iframe in your website and then just put your chatbot in there. And then from here, if you scroll down, there's a whole lot of different channels that you can use. You want to use Facebook, you want to use Skype for Business, Telegram, Slack, Line is very new. So we should add and support the channels. But how it's going to look like is, for example, you want to add it to Facebook, you click Facebook, and then it will supposed to show for. So let's wait for it. Okay, so here, it's asking you to configure your Facebook channel. Because when you're adding a chatbot in your Facebook page, in your Facebook, it's supposed to be a Facebook page, okay? Not just a Facebook account, but a Facebook page. From here, it would then ask you, what's the Facebook app ID? So this is for the developer part. What's the app ID? What's the app secret? What's the page ID and page access token? You put that, you can get all of those information in your Facebook account. And then once you do that, you say it will already start working. So like in this case, so if I go back to channels and advance this, since it's already working in like maybe just start. So here in Skype, I want to try it out. What's gonna happen is I'll click it and then I can add contacts. And then we'll open up the Skype, we'll install the bot or add the bot in the contacts, and then you're ready. That's it, but it's asking you to sign in. Okay, so we go to Skype. Then we go to get started. Here, just using a messages here. You see that? So here, okay. So now I already added the bot here. As simple as that. I just click the button, add it to the contacts, and insert it up and working. So I press type here, Google versus loading. That versus loading something. I don't know it's properly ready. But maybe it's internet connection, maybe it's not, I don't know. Because that's like a 7 wonders in the world, right? You would prepare your demo ahead of time, it's working perfectly fine. And then when you do it in front of everyone, and there's people, it's gonna stop working suddenly. I don't know why. Why is the software doing that? Okay, so, but you get the point, right? That's how it's gonna work. So, and then from there, it's okay, you can play around with this, you can already bring it to different channels, you can bring it to Skype, into Teams, into your own website, or mobile app, into Cortana, whatever. And then that's it, you can already deploy it to those channels. So that's the way. So here, you already have this part. Last thing you would want to do is to evaluate. So evaluate. This is very, very important because you can have all the features in your chatbot, you can make it as smart as you want. But at the end of the day, you don't know how to validate it because I would work with customers, and one of the most important questions that my customer would ask me, and in fact it is the most common, whether this chatbot is going to be used internally or externally, is that at the end of the day, how am I going to validate the chatbot? How would I know if my chatbot is making sense to my users? How am I gonna know if my user messaging this is how am I gonna know if my bot is responding properly to my user's inquiry? And it's really important because if you don't have visibility on that one, you wouldn't have any idea if your chatbot sucks or not. Unless you have an angry customer who would go up to you personally and tell you, what, your chatbot sucks. So so by default, we already have analytics here. As long as you have the app insights, you have an analytics here. Which will show you what maybe they made it for a second, maybe not. But when here, okay, while waiting, okay, there we go. While waiting, so what's happening here is that you can see how many users are messaging your chatbot, and in what channel. How many users are messaging on your Facebook channel, how many users are messaging on your Skype, and all that. But then if I scroll down, that's the only thing we can see. Again, it doesn't answer a lot of questions. It doesn't answer the question on how is the chatbot responding to my users. We don't see it here. We only see how many users are messaging our chatbot and when, but we don't know the quality of the response, right? And so this is where my next demo will come in, which probably I did for 5 minutes. So, but basically, that's the missing question here. That's the missing feature in this analytics. So, but okay, I have 10 minutes left. So that's the idea of Azure Bot Service. Now, last thing, this is mentioned. I'm going to be quick on this one. Last thing I want to show you is part of the release of September 2018, Microsoft Bot version 4, is that we have this enterprise bot template. Because earlier I showed you here in this part that typically when you would build a chatbot, you would also use different AI services. And you would notice this as a developer, you would build a lot of projects, you would do a lot of projects, you would build a lot of chatbot, and you would notice that the same AI, you would notice similar AI services that you're using. That in this project you're using these AI services, but eventually in this other project you would also use that. So with enterprise bot template, pretty much all of the at least the basic level, the natural language processing, the question and answer, maybe the basic factors verification, the analytics is there. So what the enterprise bot template provides for you, so you'll see that it's in the documentation, it's available online, but this is the only source for that. as of now is that it already contains all these basic features. Like it already have the introduction, like the indicator, as if you're talking to an actual person. There's the GUI, so I didn't focus so much on this, but again, this is part of the cognitive services. And then there's a whole lot more. But I'm not going to go again into details since I already have probably 4 minutes. But the idea is, if you go here to get started, it will provide you the option on how you can use this method. Because if I click to get started, we'll do it again for 2 minutes. But it will show you what are the prerequisites. That here, okay, from here it's using .NET Core, it's using NPM, it's using Blockchain Creator, and then you need all these CLI tools to set this up. Now, so it shows all the how to deploy your project and all that, but again, since I'm already in the documentation, I don't focus so much. But important to note that again, this is open source. So if you go to GitHub, you go to this repository, /Microsoft/AI, you will see this template. And again, right now it supports C#, .NET Core, and then Node.js, which is a form of TypeScript. For now, I'm using C#, I'm using .NET Core, and this is how it looks like. Just here, I already have the provision ahead of time because I don't know that I don't have function here. So I'm going to load this, yes, and then I'll use the production endpoint. So here you have the option. Do you want to test it locally if you run it locally, or if you want to use it in production. So in production, it's the connecting code, and just remember the internet connection. So I hope this works. So let's start. It's supposed to show me a production part. My internet, okay, so it's super good. Okay, so that's right. Okay, so part of it is this part over here. Yes, because earlier I've shown you in the Azure bot that it can only show you this much when it comes to analytics, right? It doesn't answer a lot of questions. But using that enterprise bot template, because part of the code is it's already integrated with the telemetry. So when you open up the Power BI desktop, it will show you a whole lot of stuff. Analytics, like how many users, or what are the critical words that that my users are telling me. So it's here what, when. And then from here, demographics. Where are my users coming from? So right now, there's just Philippines, and then I haven't seen before. I don't know how they saw it. And then transcript is, this is where you will see that, okay, the user said this, and what is their reply in chatbot, right? So it's a much more detailed analytics that you can use for your chatbot, and this answers the question of my users, of my customers, that how can they validate your chatbot? And there's something more, even in I don't know how they even in the sentiment analysis, are they angry, or are they happy? Things like that, but I don't have it integrated here. But the point is, it's there. You already have this template. Do note that this is a template, because again, you might be wondering, I'm learning Microsoft Cloud Framework, I'm learning Cognitive Services, I'm learning Azure, and I'm not preparing to understand how to do Power BI. No, so the idea here, just go, because I'm actually, personally, I don't know how to use Power BI. So time's up. Last thing to show you that it is available here. You can download that template here, including the Power BI template. Okay. So time's up. Thank you so much. I hope. But I think we have 10 minutes Q&A. I don't know. Do we have? But pretty much that's it. I hope you learned cool stuff here. But we have Q&A session. Who's gonna ask? I don't know. Maybe I should ask my bot. I don't know, but yeah, I think pretty much that's it. Thank you so much.
We're all excited. I hope I can keep the level of energy this afternoon. So, okay, as developers today through Cognitive Services, as I've said earlier, you have more power. Because what we do is through the cognitive services that we have developed based on the breakthroughs we have in AI in the past several years, we are making this cognitive services enterprise grade. When I say enterprise grade, we will be able to use and deploy these solutions across your different enterprise applications. So what this research tells us is in the past several years, we've achieved human parity in 4 areas. That's object recognition, speech recognition, machine translation, and machine reading. So when you look through all of the services we have in our Azure Cognitive Services library today, you will have this level of human parity. Now, all of these breakthroughs will not work without us providing tools and services for developers to use. So that's why these are pre-trained APIs that we've deployed in our cloud, which is on Azure, so that you as developers can just call on the API and integrate this with your apps. So that's the intention. Here, very simple illustration on how we're going to go about today. You have your applications and you have cognitive services. To create full-blown apps, we recommend using our Azure Web Service so you can have a scalable web application at the front end. And if you want to integrate to different types of other systems, which resides, for example, on-premise or in other cloud environments, we can make use of what we call Azure Functions. So these are what we call serverless compute stuff that we can actually integrate apps with. So this is where we are. The focus of my session is to go through and walk through the cognitive services piece. Okay, so when we think about cognitive services and adding intelligence into your apps using these services, we have 5 areas. One is vision, and then speech, language, knowledge, and search. When you look at what we have, so we have pre-trained models, this is what I've been saying all along, but we also have customization or models that you can customize. Later on, throughout my demos, I'll show you how you can train a very basic custom vision API. Now, let's walk through what we have. So in this case, everything I'm showing you is accessible by you. We have services that you can try for free, and you can find this in aka.ms/cognitive. When you do that, you have, and you will see the 5 areas that I mentioned earlier. You have vision, speech, language, knowledge, and search. Now, specifically for vision, these are really APIs that you can use to identify and analyze content and images. So what do we have? We have image classification, we have scene and activity, we have celebrity, landmark, and as I was saying earlier, we have OCR and ICR, so we do handwriting demos. Now, aside from this, we do have video indexing. So this can include face detection in videos, object detection in videos. We have face detection. We have personal ID. So when you were doing cognitive services previously, our very famous demo was called Sophia. It allows you to identify individual faces. So we're doing this in several of our customers today where you put the face API on the edge. When you say face API on the edge, you put it on the cameras. Like for example, if you're in a bank, you have your bank branch, and then we can identify people coming in and out. Now, today what we're doing is counting unique images. Because for us to be able to use the image, the person going there, you have to provide consent. So if you're a banking customer and you want to be able to use your face as your identification, you as a customer have to provide that consent to your bank or to your service provider. Once you do that, we can do face identification and we can do face recognition. Now, we do have content moderator. Content moderating is important so that your machine learning or your models will not get inappropriate content. So that's what we've learned while we're doing all of this. Now, let's go to computer vision first. If you haven't seen this, then if you click on computer vision, you have the tools available for you to try out. We have a very simple sample here where you can select images, and as you select images, what the API will give you are really this. So this is the output of the API. You have objects, the objects plus the confidence level. So the confidence level in this case for sky, it's 99%, outdoor 99%, and so on. So you'll see that. And all of the objects, tags, description can be accessible through code. So all of that you can get as output, as parameters to your code. We also have, and this is the OCR piece, you can have a lot of images. Like in this case, you can have a sign even if it's skewed. Our OCR engine can actually detect that. If you look at this, this is preview. So closed when one door closes, another opens, etc. The output again of the API is this. So it's a JSON file. So if you're a developer, you can easily cut and paste the output of this API and make use of whatever parameters you will need in your application. That's the intention of what we call pre-trained models. We even have handwriting recognition. So in this case, you can try it out by putting in your own handwriting and see if our engine can actually identify it. So I can go on and on. You can actually test all of these. And upload your own images to see if this particular pre-trained model is actually suitable to your requirement. Now, the other piece that we have is speech. So since this is a very noisy conference room, I cannot demo speech to text, but you can try it out in your own environment. We have speech to text, where there's automatic speech recognition, there's text to speech as well. Just like Face ID, we also have speaker recognition, and we have speech translation. The best way to try it today is using the translator app. If you have a Windows device or a Microsoft device or an iOS, Android device, you will see Translator, the Microsoft Translator. You can download that. This is making use of our cognitive services features. So in this case, I have a basic translate. I can type in a text, or my input can be voice. My input can be an image with text on it, so it will automatically do that OCR and ICR for you. So I can type something. I can type, let's say, I'm happy today. So, and this is a Filipino translation, so medyo accurate naman, masaya ako ngayon. So you can test this out, different language, you can have a different source and a different target. Again, this is available on your phones, you can try it out. Now, the next one is all about language. So here in language, we have text analytics. Now, text analytics will come important when you go to the next session, which is about cognitive search. You have here, with our text analytics, we can do named entity recognition, key face extraction, and sentiment analysis. Now, to illustrate this, we have an application called Intelligent Kiosk. Now, the Intelligent Kiosk is also a free application that you can download. So notice I'm not selling anything here. Everything is for free. You have Intelligent Kiosk. The code for the Intelligent Kiosk, as promised to some of you, I will show a bit of code, is actually available in GitHub. So I'll get to that in a bit. But what it gives you are sample demos, meaning sample applications on how you can use each of the cognitive services APIs so you can get started quickly. So as you can see, we have a pattern here. We want to be able to create the template for you so that you can easily add it on to your apps. Now, I have here one of the search capabilities I want to do is a Bing visual search. What's a visual search? I can select an image, like for example, a house. So I can have a photo of a house on my machine or on whatever device you have. So I can have a photo of a house, like for example this. If I select that, what the Bing visual search will do is, based on the characteristics of the house you selected, it will go through the web and look for similar images. So for example, yung application in the real estate environment, if you're selling something in real estate and you have a lot of pictures of houses or subdivisions and you want to look for, I want to see the same size house but in a different location, you can do this. This is a Bing search. And again, these are all pre-trained models. Now, there's one here. I'll go back to my demo. There's one here called Custom Vision. Custom Vision is a vision API that you can customize. What does this mean? I can load up objects and I can train it up so that I can identify certain scenarios or certain types of things that you want to identify. In this case, this particular Custom Vision API is pre-trained for identifying basketball game objects, for identifying traffic conditions, vehicle category, and weather conditions. So if, for example, I choose the vehicle category, again, I search for an image of a car. So this will go through an image search again. Again, if you have your own image of a car, you can try that. And let's say, for example, I want to choose something fancy, like this sports car. If I select that, what this will now give me is a result. Based on how I've trained my model, this particular car is 100% sport, 19% SUV, and 18% sedan based on its training. So if you're going through an image classification app, you can say, okay, I'm 100% confident that this is a sports car. So that's the idea here. Now, as you've said, this is a pre-trained model. How can you use the same thing in your application? Now, let me go through Custom Vision. We have a site called customvision.ai. When you log in, you can actually create projects. And in this case, I can create a new project. I will name this my Future Now project and Future Now demo. I can identify what I want this to be. Is it image classification or object detection? When you say image classification, that one image will be classified as a particular classification. But if you say object detection, it will detect objects within a particular image. So that's the difference. Here, I have classification types, I have domains. For you to get a more accurate result set, you can actually identify a particular domain closest to your scenario. In this case, it can be food, landmarks, retail, a person, and so on. Right now, I'll choose general and create a project. Now, the first thing it will ask me to do is training. So remember, when you have a model, just like any other machine learning model, the first thing you need to do is train. So you have a training set. And then we will test it later on based on how you train the model. So that's the process here. So how I will train this is I will add images. And for this particular project, I will add images of dogs. So I have here about several images of dogs. Click open. So notice that this 15 image will be added. I'll put in here dog as my tag. Upload. Again, basic training. Once I've uploaded this, all of those images will have dog as a tag. And for example, I will look at this image and then I can add another tag and make it a puppy. Puppy. Save and close. So I have now dog and I have puppy, which has one. So I'll add more image here so we can keep training our Custom Vision API. I have a picture of a cat. Upload all that. And I have 16 images. I will, again, add a tag called cat, upload it. Okay. So I now have several images here. I have cat, dog, and puppies. I can even like add another tag. Let's say for this one, this is a kitten. Save and close. Okay. So, I can keep on adding images, I can keep training this, but let's say I want to train it based on what I have already, based on the 16 plus 15 images I have, and the 4 tags, and 2 tags. Tags, wait, let me see. Let me just keep on tagging this. Oh, sorry. Kitten. Okay, no. For the interest of time, since I don't have a lot of time, I will remove the 2 other tags. So I can just use this. Train it first. Okay. Let's train this first. Yeah. Now, once you've trained it, the next step would be to test it. And to test it, we have quick test. And in quick test, what we can do is I can have a test image. So in this case, I use a training data, and I have a test data. For the test data, I have your test data. I have a picture of a dog or a cat. So let's try this one. It's an upside down cat. And just like what we had in the custom vision, in the intelligent kiosk demo, you have here your tags where this is a 99.9% probability that it's a cat and a 0% probability that it's a dog. Now, okay, once I've finished testing and training, I can actually look at the performance of this particular model. And right now, since I only have very few data, my precision and my recall is 100%. So depending on what you're training, your precision and your recall will be different. And once I've done this, the next step would be, how do I now use this in my application? So I have here prediction URL. If you have an image URL, you can use this code.
What we are going to do is, I'm going to just explain the agenda for this afternoon. So I'm going first to explain a little bit what is machine learning in the context of AI. Then we're going to go through the different things that we can do with machine learning, what it is meant for, how can you start your machine learning journey, and then I will jump to the demo and show you how some of the stuff that we can do to start with. Okay, so first thing, and I wanted to just to give you a little bit of overview about how we position machine learning when it comes to AI. So when we talk about AI, it's actually a lot of different capabilities, but generally we classify that in 2 different boxes. One is what we call cognitive services. This is what you saw just now with Jack. And the other one is what we call machine learning. So what is the difference between both of those different capabilities? So cognitive services, you heard Jack mentioning that, is pre-built models. So cognitive services is actually services that are trying to reproduce human-like capabilities and put that into a machine. So basically whatever we can see, whatever we are using as speech, all our capabilities as humans, we are trying actually to put that into machine and make them actually reproduce those capabilities. Machine learning is the other way around. It has no assumptions about human-like capabilities, but it is using data to actually respond to some of your questions. So basically, it's going to identify from the past a lot of patterns, and from that, it's going to generate a rule which is going to predict the future. So those 2 actually aspects of AI are very much complementary, and sometimes you can even use both of them to actually do your AI. Generally, we call machine learning the strong AI. Why? Because it is using really the broad and custom information that you have in order to respond to the questions that you get. While cognitive is more weak AI because it's pre-built, it's based on human-like capabilities. Of course, you can customize it and make it stronger, but this is what we start with. So. When it comes to machine learning, why it is important, of course, not because only the algorithms. The algorithms, to be honest, they've been there forever. Not a lot of real new algorithms have come in place recently. What is really the difference is the ability really to handle very big data platforms. Because the way we were doing machine learning 10 years ago and the way we are doing machine learning today is completely different. You don't need to sample anymore your data. You can actually use the data as it is and start to learn from that. The other thing is the ability to compute. Because one thing about machine learning, which is very important, is the timeline. If you are able to build a model that is giving you information 3 weeks later, then, I mean, for you, it's not going to be useful anymore because you need it like three weeks before. So you need to have also the ability to compute on your data, to compute on your modeling process, and be able to use the whole technology that you have. So I said you can actually combine machine learning and cognitive services together. This is what we call deep learning. So you guys, you probably heard about neural network, this kind of very tricky and scary words. So what neural network is doing, or deep learning in general, is just actually trying to use the data and just mimicking whatever the neuron are working, the way that they are working in your brain. So it's basically using all the links together. Same as the brain, when we are using neural network, it's not very analytics friendly because it's very hard to understand what's the root, what's the pattern, but it's very strong when it comes to predicting the future. So deep learning is something that we use very much when we have wide range of data and we want actually to predict very fast something that is going to happen. So I will give you some examples later, but it's basically more from a predictive perspective than an analytics perspective. So what can you do with machine learning? You can do a lot of things. So here I'm just going to give you a list. So it gives you an idea about, depending on which line of businesses you're going to work with, types of things that you can actually achieve, but of course it's not exhaustive. And I used to say that the only actually limit of machine learning use cases is your imagination. So it's all about solving some problems. So one of the area where we've seen a lot of machine learning, and I think this is where everything started initially, is marketing and sales. Why? Because when you look at marketing, they have a lot of pressure. They have to do good targeting. They need to have actually a list which is relevant. They need to target the customers not every time, but only when it's relevant, sending them the right message, the right product, and so on and so on. So in marketing, imagine how machine learning can be so powerful because they have most of the time information from their customers, customer behaviors, past purchases, these kind of things that can really be used in order to build up those machine learning models. So anything around marketing optimization, anything around propensity to buy, propensity to churn, these kind of things is very good use case for machine learning. Of course, we think also about sales and demand because this is another area where machine learning is used very much. When you want to do demand forecasting, you want to do supply demand forecasting, this is very much handful. Other aspects, operations, we think about predictive maintenance, and IoT is actually one of the area where machine learning is very powerful. Why? And especially deep learning. I told you deep learning is not analytic friendly, so is IoT. So when you're doing predictive maintenance, for instance, or quality improvement, and you want actually to fix a problem and generate a rule which is going to tell you which are the assets that are going to fail, you need to have also a powerful solution that can actually run on top of that. And this is where deep learning can be very much useful. Other area, fraud and risk, especially if people are working in banks here. We know that fraud detection is one of the area where we use a lot of machine learning. Why? Because it shows you, it takes actually also transactional data, very, very wide range of information from a historical perspective, and then it is able to detect whenever there's an anomaly, whenever you're able to find something that is suspicious. Other area, finance and HR, this is quite new. They're not as experimented as marketing guys. They started, HR specialists started to use really machine learning just recently, maybe 2 or 3 years ago, especially with LinkedIn, because they started to have a network of people. They're able actually now to really gather a lot of information from different resumes and so on. If you have to do it manually, it will take you ages to really, identify who is the right profile to target for this specific position. But when you're using machine learning and combined with cognitive services to do image research, this kind of thing, you can really go very fast and really identify the right people quite efficiently. And last but not least, a lot of things are done around, you have heard about AI for good. So we are working a lot on very industry specifics to also help to make the world better. So we have a lot of use cases also on that portion. So where can you start your machine learning journey? So a lot of people will tell me like, yeah, I want actually to start my machine learning journey, but I don't know where actually I should start. So what I would say is that it depends on the maturity not only of the people who are doing the machine learning, but also the maturity of the data platform. How mature is actually the company in terms of handling the data? How mature is the company in terms of also use cases that they want to go through? So if you want to start very small, like I want actually to see the benefits of machine learning through a very simple use case, and this is what we will see in the demo. You can start with Azure Machine Learning Studio, which will give you actually the ability to test some capabilities from machine learning perspective, but also it will give you the opportunity to learn. I always say that because whoever you are a developer, or you're a business user, or you're an analyst, you know nothing about machine learning, you need to start somewhere and you need to understand what are the concepts behind machine learning. Because even though if your role is only to deploy the machine learning model, and this is what we're going to see on also the solution, you need also to understand how the people who actually build up that role, how they did it. And be able actually to understand what is behind the scene when we are generating a predictive role. So you have different stages, as you see here, of maturity, depending on where you are in your machine learning journey. But if you start with stage 0, doing some customer analytics, or stage 1, where you're able already to do some churn detection, you can already actually use Azure Machine Learning Studio. This will give you the ability to build up simple models and be able to deploy them into production, and we will check in on that. Then, of course, if you want to go further, you want to do like big data, very wide range of data, complex and structured data with different types, GPS information coming from images, PDFs, and so on. You will need to go one step further and go for a journey which is more advanced and predictive analytics. In this case, you will use other type of solution, and Doug, my colleague, will talk about it later. If you want to go even further, do what we call real-time prevention. So we talked about the fraud detection, which is one of the use cases which will be concerned by that. Or predictive maintenance is another one. When you want to do this real-time approach where you cannot actually afford to spend even one day building the model, you need actually to always maintain actually the cycle and the accuracy of your prediction. You will have to go one step further and have very much evaluated solutions. Okay, so I will go with the very basic, which is Azure Machine Learning Studio. So Azure Machine Learning Studio, what it is, it's not only a data scientist solution. It's really a solution which is dedicated to people who want to start with machine learning. So basically, you're a developer, you're a business analyst, you're a data analyst. You want to start with a tutorial. You want to understand how it works. behind the scene, because machine learning process is not as complex as we think. We always see all these algorithms and we think like it's only a mathematics formula. We made it actually simpler for people who are not familiar with this mathematics algorithm, so they can pick up and start their journey with it. And the real cool thing about Machine Learning Studio is that you can deploy straightforward. And this is where, as developers, you will really find the real value. So one thing about Azure Machine Learning Studio is you can try it for free. It's free, you can have it for 60 days, you can do as many tutorials as you want, and then try different options. And once you go to this azure.ai, gallery.azure.ai, you can actually access all those different experiments. So here you see in the Azure Gallery, you have different options. You can actually filter by industry, you can filter by solutions, and here you can even go directly just to experiments if you want to see only experiments, the ones that are doing step by step for you to understand what you're going to do. And most of the time, the experiments are going to be built on Azure Machine Learning Studio. So here, there are a lot of different options. They recently added. So for instance, you see here, there's one experiment that has been built on Give Me Some Credit. So how you can actually identify as a banker who are the customers that are most likely to be a default from a credit perspective and the ones that you want to give a loan to. So there are some examples that are very much business oriented, some others that are completely more data engineer oriented. So it's up to you, you can search and find it. So here what I'm going to do is I'm going to go to Azure Machine Learning Studio and show you actually an experiment from scratch. So when you do an experiment, so it's here on the Azure Machine Learning Studio, you see there are different options. Data sets if you want to load your own data and start to build some models on top of your data. You have the experiments where it's actually the area where you can build up your own experiment, and this is what we're going to choose. The project is once you did the whole experiment, including the deployment and including all the data sets and so on, you can actually save that into a project so you can actually organize your work. So here I'm going to build an experiment. So when you build an experiment, you have different options. You can either start with a tutorial. So I have no clue about how to do whatever, so I'm just going to start with a tutorial and sample data, just show me how I should actually do it. Or you can start with your own experiment and your own data, and this is what we are going to do. So blank experiment, you'll see here, resolution is so bad, sorry. Okay, so the good thing is that I can reduce here, make it, okay. So here you see it's mostly drag and drop. So you have all the functions, all the capabilities in here. First thing that you do when you do any machine learning is to define what data you are going to use. So here on the drag and drop, you can either choose to take a data set that you have already built. You can also choose to actually connect to any database or any other blob storage that you have where you have some of your data. It can be through a URL or through a connection. Or you can even connect to on-premise database such as SQL Server. So depending on where the data are sitting, you will do the right choice for your data acquisition right here. So for us, we are going to choose data that I have loaded, which are information about income. So here my idea is I want actually to learn from data where I have already information, what is the profile of the people who earn more than $50,000. Okay, so I want to identify the profile, but I want also to know at the end what will be the output if I get some information from one specific person here. What will be the probability that that person earned more than $50,000? Okay, understand the business objective? So let's go. So I have a data set here that I'm going to show you. It's a CSV file where I have actually information about the people who already filled it. So it's basically information which are profile information. So I have the age, I have the work class, I have the education, the marital status, the occupation, the relationship, the race as well. This is coming from the US. Race is very, very common question there. The gender, I have also capital gain for those who have shares, number of hours worked per week, the native country, and then the most important, the income. More than $50,000, less than $50,000. So I'm going actually to use that information to build my model. Okay, so I'm going to do it the very straightforward way in the first place without evaluating my model, just to show you first what is it to actually really build the model. Then I will explain to you why you need first to evaluate your model, what it is meant for, and what's the point of the whole process. Okay, so here what we're going to do is we are going to train the model. So train the model is exactly like training humans. It's actually learning. It's actually trying to learn from those data that we already know what is the best rule to apply to other data where we don't have the information about the income. This is basically what it means. So when we say we train a model, it's actually we learn from the data. The model, I need actually to give some inputs, is an algorithm. So what type of algorithm I'm going to use in order to build this model. So basically when we talk about algorithm, they're all classified in 5 types of functions. So there's what we call classification. This is the most popular type of algorithm that you will find in machine learning. So classification is the one that you saw with Jug, with the dogs, exactly the same. So is most of the time binary question. So is this person going to earn more than $50,000? Yes or no? Binary question. Is it a dog? Yes or no? Binary question. So this is the most popular algorithm, and it ends up with a probability. So it just actually to identify what's the probability that you're going to head to a certain direction. Then you have what we call regressions. Regressions is more about evaluating and predicting a value. So for instance, I want to do demand forecasting. I want to know exactly how much the volume of cells that I'm going to sell. So this is a volume, so it's a number, and this is another type of function which is called regression. Then a third one is segmentation. Segmentation is clustering. It's basically putting people in a brackets that have similar behavior. It can be people, it can be also stores, it can be actually anything. It can be your assets, depending on what you want to do. It can be supervised with a real business question, or completely unsupervised. You don't know exactly how to put people together, so you just put a lot of different information and you try to figure out what makes them, what creates affinity between them. So those are the 3 most popular. Then you have also what we call link analysis and time series analysis, which are 2 other different type of algorithms. So basically, when it comes to algorithms, I always say the same. People are a little bit confused because they don't know which algorithm they should use to start with. The algorithm is not the answer to the machine learning. Algorithm become important where your data are very poor. But when your data are powerful, whatever is the algorithm you're going to use, your model is going to be good. I mean, then of course you have to apply some of the rules from the algorithms, but we have tutorial also to help you with that. So let's use one of the classic algorithm, which is called logistic regression. So logistic regression is very much used in risk because this is an algorithm which is very well done when data are not very much correlated. It means that the data themselves, they're not very much related, and you want actually to use different types of inputs to get the outcomes. So here I'm going to do one more thing, which is defining for the training what exactly I want to predict. So here I'm going just to select the label, which we call the label, which is actually the target. Here, remember, I want to actually predict the income. Okay, so I just select that this is the income that I want actually to trade. Okay, so here I am. I have my my data, I have my training. I am not evaluating the model right now. I'm just going to build the model and apply it straightforward, just to show you actually the whole process. Then let's assume I want actually now to apply this model to a new set of data where I don't know if people actually earn more than $50,000 or not. So here what I'm going to do, I'm just going to select this new data set, which is just here, and it's called income. Here I go. Not on the samples, it's on my data set. All right, here we go. So you have also a lot of sample data if you don't have your own data set that you can use actually to play. So here I'm going to apply my model that is trained here to my data set. But I will need for that to score. So scoring is, so training is to learn, scoring is deploying. So it's actually applying the rule that I learned from my initial data set to another new data set. So here, I'm just going to pick score model here. Here I am. And the score model will actually require the outcome from the training model, and it will require the data set that I want to score. Okay, here I go. So now I'm going to run the whole model. So here, I'm not going to bother you with the analytic portion and so on. I want to show you actually the deployment portion, which for me, I think as developers will be more important for you. I did here build my model. It means that I did generate the rule, which is telling me who is more likely to earn more than $50,000, and I did apply it to a new set of data of people who I don't know about their income. So we can just go in and check visualize the scored data set very quickly. So those are a new set of people. I don't know their revenue, but I have at the end a probability. So here for each person, it gives me the score labels. This is the highest chance. This one is probably less than $50,000, and the probability is 10% that he earns more than $50,000, and so on and so on, for all the people that I have actually scored here. So now imagine I want actually to deploy that rule into an application. So here what I'm going to do is I'm going to set up a web service and generate a web service from that experiment. So I say, okay, this experiment is good. I want actually to generate my web service, and I will show you then. Okay, so here you see, it will just like automatically put, so I have to run it first. So I run my web service first, and then I'll be able to deploy it and show you also the outcome. Okay, here I am. So then I can deploy my web service here and see it from my Azure Machine Learning Studio. Okay, so here I am. I have deployed it. I have already the API key, and I can go and test now the outcome. So here from the Azure Machine Learning Web Services, I can either go and do some testing, which is straightforward. So for instance, I want to know, let's just pick a sample data. So here if I take this sample, random person, 39 years old, state gov, male, white, if I test the request response about is he going to earn more than $50,000, yes or no, I will see here I am. So probability is 10%. So for that specific person, if I change, so for instance, let's assume I'm going to change here from state government. So I'm going to put private, for instance. I'm going to put husband, okay? I'm going to put that he is in a relationship, he's married civilly. We said that it's a man, and what else? Maybe I can also change the education, like put that he is on the master. And yeah, so let's now retest and see what's the outcome. See, much better probability, 29% almost probability, but still less than 50K for that specific person. So what is missing is the occupation. Of course, if it's in administration, You might not make a lot of money. Okay, so now if I'm an executive, okay, I have almost 50% of chance to earn more than $50,000. So this is things that you can set up quite quickly for your business users to do simulation once the model has been built. But what I wanted to show you is this portion, which is the consumption portion. So now imagine I want actually to generate my model into code. So it can be C#, it can be Python, it can be R, and you want actually to integrate that into your applications. So you see immediately you can generate your C# code which is related to that specific model, so you can integrate that into your applications. So here you go. You can see it here immediately. So here the nice thing about Azure Machine Learning Studio is that you can really start quickly with some very simple use cases, and you can from that build up your model, deploy your model in a web service, and even be able to generate the code that you need actually into your applications.
So outside of social media and outside of the modern smartphone, I think one of the greatest innovations coming out from the internet in the recent years is search. Search changed the way we look for content in the internet, and search was able to enable a company to build a whole company out of itself, and that's Google. But for this afternoon's presentation, we start with a typical problem with most of the companies and organizations we have today. We have a lot of documents in our archives, and we want to get more value out of these archives and documents. And with the day-to-day transactions that we make, we're producing a lot of data. And this data is now in the quintillion bytes. And quintillion, I think, I forgot the number of zeros. So I think quintillion is an exabyte. So you have a megabyte, you have the gigabyte, you have the terabyte, then a petabyte, and an exabyte. That's how many zeros and how many large amount of data we're producing. And 80% of this data is unstructured. And with that, it's like the traffic in the Philippines. We're losing value in terms of productivity in searching through that pile of data. And to enable us to mine that data for more information, there is AI to help. So Jack showed you earlier how we can use AI, the different cognitive services that Microsoft is offering. And one of the cognitive services that we can easily consume and use in the applications that we're developing, especially in search, is the ability to recognize text. So she demoed earlier that through ICR, we can even have the ability to detect handwritten text. And not only text, we can also detect features in an image. So given a sample image, we can see that this is a girl playing basketball or throwing a ball. And going into more specific applications for your businesses, for your organizations, it's being able to digitize that content in all the documents we have and all the forms we have through AI. So traditionally, how document management has been done is you scan a document, you identify certain regions and certain margins for optical character recognition, or OCR. But through AI, we just scan the document, and AI would be able to determine the specific location of the text, the X and Y coordinate, and put the bounding rectangles or boxes to that specific text. And as a refresher, so Jack gave earlier of what are the AI services we have or the cognitive services that are available. And this encompasses the 5 pillars that you're seeing now. And these 5 pillars are from vision to speech to language to knowledge and through search. And for the knowledge mining piece, most of the focus would be on the knowledge part and search part, and enabling this through AI with the abilities provided by the vision and language capabilities. So what is knowledge mining? So in a nutshell, knowledge mining is unlocking more information from the documents that you have. Specifically to the HR questions that were raised earlier, it's having that ability to be able to scan all those resumes and CVs and digitize them, put them into an archive. And from that digitized content, we do AI to detect all the text and features of each of the document. And at a high level, the capabilities that we provide through Azure is the ability to ingest this data. Of course, the scanning part is something that has to be done through scanning devices or a camera. But from all those images that are produced, usually we just put this in a shared device or storage. But from that storage, the ingest piece is being able to load that data from that storage and into the cloud. Now, why do we want to load it into Azure? Azure provides that compute capability to be able to apply all those AI algorithms on that documents and content. And this is now where we go to the enrichment phase of that business process or the flow. And in the enrichment, this is where we apply the cognitive skills that I've shown earlier and Jack have shown earlier. And these cognitive skills will provide you with the necessary annotations. So first what happens is the document is, we call it the document is cracked or cracked open. And when we crack open the document, we extract all the sentences and the words from the document. And using the NLP or natural language processing, from all these keywords, we try to identify people, places, organizations, or certain entities relevant to your organization. So for the HR example, for example, we can enrich that content and match it to skill sets. And with that rich set of database, we want, of course, to expose that in a very usable or web-based platform through a search. And with all those information, so this is all a subset of the AI that can be done for that document. So you have key phrase extraction and removing all those stop words like the, of, and, of course, those are not relevant to the content of a document. Then we need to extract the organizations or certain organizations that are inside the document itself. If we detect the document is an image, we can do a face detection or image classification. Then we can do a location extraction, comparing it to a large database of the most known cities, municipalities, provinces, and countries. Even persons entity. Persons meaning the name. So most common names that are inside this lexicon is also extracted. We can also do the celebrity matching and landmark detection in images. And when it's now detected as text, we can do sentiment analysis. So we can say if the overall sentiment is positive, negative, or neutral. And of course, we can also do some hashtag extraction and printed text recognition. And after applying all this AI to those documents, this enables us to build this graph or this indexable and searchable index. So what is the Azure Search difference? First, we provide you with an effortless search engine. So effortless meaning less of the coding and more of the configuration. Since this search service is API-driven, it's mostly REST calls and the exchange of keys and tokens. So there's no need for you to write very deep native code like C# or Node.js. It's more of identifying the sources, applying AI to that sources, and getting that API and using it in your search application. Of course, in Azure, it's also automatic scaling because it's the cloud. And with auto scaling, we don't need to budget for capacity from the start. We can start small and grow the search application as needed. We can ingest both structured and unstructured data, and we can put it in any of the Azure storage solutions. So it can be a blob storage, it can be big data, it can be SQL. And all of these are available out of the box. So just configure and publish it to the app service. And after doing that configuration, it's also easy to integrate with AI. So the real value of Azure Search is applying AI to all those documents, especially the vision, the language, and the speech capabilities of the cognitive services. And it's easy to customize to any business need. So in the later examples I'm going to show, it can be for an investigation, it can be for legal, it can be for HR, it can be for clinical trials, or it can be even for job search. And with Azure, we're making sure that all data is in a secure platform with all the necessary locking down of that data with the right trust. Of course, we provide it with the privacy and controls that you can link with your Active Directory, and we want it to be compliant to most of the industry standards and have that high SLA. Like when we need something, we usually go to open a browser, do a search. We want that search to be low latency, fast, and provide the results immediately. That is very relevant to what you're needing now. So with that, let me go to a short demo. So everyone familiar with JFK or John F. Kennedy? So JFK was the president of the US in the 60s who was assassinated. And in 1992, there was an act of Congress that mandated that all documents relevant to the JFK assassination be published to the public. So with this publicly available content, Microsoft Research decided that this was one of the content that we can showcase our search capability. So by the December 2017, there were around 30,000 documents, around 300,000 pages related to the JFK assassination published online. And with this, the engineering team decided to get the digitized copy of that content, load it into Azure, and apply the AI and cognitive search capabilities into it. So let's watch a short video before we go to the demo.
Cognitive search. Cognitive search is an AI-first approach to content understanding. So no matter what shape your content's in, cognitive search gives you the ability to use all of our cognitive services to inspect and unlock all of that content and then search against it.
What we've found is that you can actually take AI in the cloud and have it do all that reading, have it do all the understanding, and then surface to you the most relevant bits of information. You could just compose the AI you want to express. What are the things that I want to extract from my documents? And it can go and extract all the information from your data source directly. It distributes all that compute in the cloud, and then it puts it and organizes that knowledge inside of an index so you can easily search it.
And while we're kind of going through this process, it just so happened that the government released all of their files from this JFK investigation, right? This is like 60 years of like typed and printed and handwritten and photographs and evidence and all these things.
We just ran all the content through, and right away you can see that the CIA, the FBI, and even Cuba was involved in all of this.
You've got a document. We needed to run like OCR on it, and we needed to run handwriting on it to find out where this thing was. So now we've got text. Then we go off and we take this text and we run all of the text through things that find entities, right? So now we've got an entity. Well, you can then link that back and you can say, here's what I understand about your content kind of in isolation. And then for anything that you want, now I can tell you everything that Bing knows about this relative to the whole world. And you can express all of that in basically 3 skills, which is really powerful.
Not only can you see that information, but it organizes it in a way that you can actually navigate the data very quickly. So what we found is we could express this as a graph, and then you can just see how each of these topics that are discussed in these documents are related to each other. And so whether you're trying to figure out who assassinated a president, or if you're just managing thousands of contracts or engineering plans, we found customers in all these industries derive value from the content that they have. You can take AI, compose it together, and unlock all the value, that latent value that you have in your content, and start putting it to good use. And all the cognitive capabilities we showed are built into Azure Search.
So you can get started today. In just a few clicks, you can go through and you can add the cognitive capabilities to your content and get it into Search Index so you can start asking these questions on your data.
And we've published the code that we have, so you can just go today, put your content into the cloud, and have the same experience that we just created in just a few minutes.
But no matter what you choose to do, I think you'll be surprised to find how easy it is to take all of Microsoft's AI capabilities and use them together in cognitive search.
So as you've seen in the video, it's less of coding and more of configuration, logging into Azure and configuring that search specific to your organization's needs. Now, let's go a little deep to the demo. So this is the JFK Files site. So it's a public site. You can search for it on your favorite search tool or on Bing. And you'll open a familiar interface. So with the JFK assassination, the most popular name that came out was Oswald, or what they call the lone gunman. So if we search for Oswald, this should give us a results of all the documents containing the word Oswald. So you'll see the tags here that were extracted for each document. So as out-of-the-box features, we extract the common names. So you see John F. Kennedy. We extract also common organizations, which is the CIA or the Central Intelligence Agency. We also see the name of Lee Harvey Oswald. We see a location, which is Washington, D.C. So each of these entities are extracted automatically by AI, and you're given this faceted search where you can narrow down your search for your investigation. So you can also detect if a document has a redaction. So redaction meaning there's some markers on the document, so we can do a filter on the documents with redactions. And we'll see these are the type of documents that has been redacted or with information not for public consumption. And we'll also see that even if we're searching for Lee Harvey Oswald, we're also getting results for GP-Floor. Now, GP-Floor is what we call a cryptonym. So the CIA has some code names for each of the persons related to the incident. So instead of putting the actual Oswald name to protect him during the investigation, they called him GP-Floor or his cryptonym. So with AI, we were able to link the name GP Floor to Oswald itself. And for each of the document, we can see the keywords that were extracted. So this is more about action film. We can open other documents. So this has more entities extracted. And we can even drill down to the actual document. So we see on the left side the image of the document that was captured, and on the right is the actual OCR result. So if I go through the document, it goes to the exact location of the word that was extracted. And finally, we can also do the graph analysis or link analysis. Now, during the investigation in the 60s, it was less of data, but more investigative work. Now with the link analysis, we can see really that how Oswald was related to certain other names in the investigation, like Sylvia Duran, which surfaced out, which she was an employee of the Mexican embassy. So now this puts some more validation into the conspiracy theories that the assassination may be related to Cuba, to Russia. And with this type of knowledge mining, it makes it easier for you to do search on other types of documents. So we have some other samples, like this Walter Clower is more on a legal, and again, it's a familiar search interface with just the search bar, and going through all those documents, like for example, search for Microsoft, will yield you all the documents with the Microsoft name or the logo in it. So we can even mine documents like PowerPoint. And again, if you're seeing, it's a familiar interface with the faceted search, with the hashtags and the result set. And finally, as Jack have shown earlier, you can use one of our demo applications that you can freely download from the web. We call it the Intelligent Kiosk. So you can search for it. And most of the demos you've seen outside were actually built on the Intelligent Kiosk. And the Intelligent Kiosk has most of the demos relevant to AI and cognitive services. And the good thing about this, with the changes in Microsoft, we're now loving open source. So with the Intelligent Kiosk, the source code you can download on GitHub. You can use for free. You can use the cognitive services for free and develop your app. And you can see from these demos that we have also the cognitive search, the JFK, the Microsoft documents. We can also search Flickr. And another cognitive search here would be where's that one? This content search and intelligence. So this was the one I told earlier, where we can also do clinical trials and search for it using tree-based filtering. So again, this is the same back end, and we can search maybe for measles, one of a common sickness now. And we can see the relevant clinical trial documents from the US related to measles. So with that, with the search capability, it's your gateway to getting your company or your organization AI enabled. And as you can see in this final slide I'm showing, AI search is just the first step in having that AI journey for your company. After AI search, you can go consume the cognitive services available in developing your app. So with all these cognitive services, They're all API driven. No particular company, not even Microsoft, actually owns Spark. So you know that it's going to be around for a very long time, right? You're not going to be stuck with a proprietary platform. The second, it uses in-memory, and its in-memory engine is actually 100 times faster than Hadoop. Because the challenge with Hadoop is it's constantly reading and writing against your disk, that it's actually your constraint. But in the case of Spark, what it does is it reads the data off your storage, keeps it in memory, computes everything across a cluster of computers, or across a cluster of compute resources in memory, and then only interacts with your disk if it needs to write the results already. And of course, it's highly extensible because with Spark, you can actually write your models, your code, in Scala, in Java, in Python, and people have already thrown in Spark SQL, GraphX, streaming, and machine learning libraries. So there's a lot of APIs, a lot of libraries that are already available on Spark today. So chances are, if you're developing your model, the only code you will be writing is the logic, not the algorithm itself, because there's a very rich library of algorithms out there already. So as I mentioned, this is how Apache Spark looks like today. It gives you a lot of flexibilities. You have all these libraries, these components, all going into Spark's core engine, and it's capable of running on a variety of hardware platform. It can run on top of Yarn. It can run on top of Mesos. It can even run on top of a standalone scheduler. Now, what does Databricks have anything to do with Microsoft? So Microsoft Azure recognizes the power of Databricks and decided to team up with them to be able to give you a first-class service with easy cluster creation, scheduling, notebooks, collaboration, and security in mind. So what happens is you get the best of Databricks and the best of Microsoft Azure, put them together, and these are the benefits that we are able to deliver to you today. So first and foremost, Azure Databricks, unlike any other cloud service solution out there on Azure, is first party. What does first party mean? First party means that when you deploy Databricks on Azure, it's not going to generate a separate invoice for you. It's just going to eat into your existing Azure credits, if you have Azure credits, or if you're running your own account using your credit card, it's just gonna charge you, it's just gonna fold your charges into your existing Azure bill. So this is not a separate procurement. It also does not involve any licenses. Azure Databricks also, if you run into problems with Azure Databricks, you don't have to call Databricks directly. You can still call Azure support, and Azure support should be able to help you. If you have TAM on the ground, if you have a technical account manager, talk to your technical account manager. Your technical account manager can connect you to the right resources to help you. So in other words, we are not going to point the finger at Databricks every time you run into problems. Microsoft is the same neck you're going to choke if you have issues with Databricks. Azure Databricks is also integrated seamlessly into other Azure services. So it's not like a Band-Aid solution that was just slapped on top of Azure. It neatly integrates into the Azure portal. It has access to all the existing Azure storage that is available. So you can connect your Azure Blob, your Azure Data Lake, or even our databases into Databricks neatly. It has connectivity to Azure Billing, and of course, at the end of the day, after all the experimentations, when you need to already provide the report, you're not going to show them your notebook, or you're not going to show them your code. You're going to show business a nice, neat report, and Databricks neatly integrates into Power BI as well to address that requirement. So differentiated experience for running Databricks on Azure. You get enhanced productivity. Everything about Azure is, everything that is available on Azure is available for access on Databricks. So you can connect to any cloud service that is available on Azure and integrate it into Databricks neatly. You can easily innovate. You can improve your collaboration. It supports the workflow. It connects easily to your Active Directory. So if you need to invite other business analysts or other data scientists into your team, it's as easy as adding them on Azure, on Active Directory. It runs on the most compliant cloud. So this is particularly important to the enterprise because, again, this is not just a tool for academics. If you're going to deploy this in a bank, your compliance officer would like to be sure that whatever data you feed into Databricks remains secure. And Databricks has features to actually address those. And then, of course, we scale without limits. We scale as much as we're able to scale any other service on Azure. So let me show you how easy it is to actually provision Databricks. So let me quickly switch to a browser. Oh, I do have a mouse. There you go. And my mouse is working. Okay. So this is my Azure portal. This is my account. I am going to provision Databricks by simply clicking on Add. And then I type Databricks. Oh, sorry. Thank you for that, Philip. Let me do a little bit of rewind. I didn't realize you guys were staring at the wallpaper. So, okay. So this is the Azure portal. I'm going to add a new service by clicking on Add, typing in Databricks. And I'm having internet connectivity problems. I should have offered more to the demo gods earlier. Seriously. There you go. So I click on Databricks. I click on Create. I simply give it a name. So in this case, Future Now PH Demo. Okay. And then I'm going to put it on an existing resource group called Future Now Demo. I'm going to deploy it in Southeast Asia. I am given several pricing tiers. I'm going to select the trial, which gives me 14 days of premium. So this means that if you have a trial Azure account, you can actually play with this one. And then I click on Create. So we just wait for it to deploy. And because I don't have much time left, I am going to jump into an existing one. So it takes about 5 to 10 minutes to actually deploy Databricks. Once that is up and running, this is how it actually looks like. So this is Azure Databricks. Within Azure Databricks, the first thing that you need to do is you need to create a cluster. So let's do just that. Let's go to clusters, and then let's create a sample cluster. Let's call it cluster 01. because I am not creative. And then I have a choice between high concurrency and standard. Of course, the high concurrency would be a little bit more expensive. I can select what runtime version I want to run. So I'm going to run 5.2. I can specify what version of Python I will be using. And this is what's unique about Databricks that is not available on Hadoop. So when you deploy Hadoop, for as long as your Hadoop cluster is existing, its meter is actually running. So it's actually costing you money. In the case of Databricks, you can actually specify that if it runs for 120 minutes, it's automatically going to tear down the cluster. So it's going to retain the configuration, but it's going to free up all the compute resources so that it's not going to cost you anything anymore. In fact, I can even lower this inactivity timer to, let's say, 30 minutes, so that after 30 minutes of inactivity, it's going to free up all the compute resources, keep the data, keep the configuration, and if you need to start up the cluster again, you can just go back to the cluster and say restart. It's going to reconfigure everything as if it never went away. Now, why is this important? This is important because, as you know, if you're an experienced data scientist who's run models across large data sets, it can sometimes take hours, even days. And what's happening is, today, if you're using other technologies, you would have a poor intern or one of your lowly data scientists stick around in the office and watch as it runs circles until the job is actually done. In the case of Databricks, you fire and you forget about it because you know that after the job is done, it's going to shut down resources for you. So no need to watch it like you're watching grass grow. Again, you can also specify the size of the virtual machines that are going to make up your cluster. So you can opt for high compute, high memory, different configurations of optimization. Another cool thing about it is that it has auto-scale features. So you can specify the minimum number of nodes in the cluster and maximum nodes. So if a job or if an algorithm is really complicated and is taking too long, it can actually spin up additional nodes for you so that it can finish faster. So let's take a look at an existing cluster. Okay. So this is an existing cluster. There are other things that is cool about Databricks. We can take a look at, before we take a look at the other components, let's go through the other slides. Okay. So, Databricks key benefits to the different audiences, because typically in a data science project, you have several roles. For the data scientist, this means that it's easy to deploy clusters. Your data scientist does not have to know how to put up servers, install software, configure operating systems, and wire up networks. They can just simply say, I need 4 nodes for this cluster to run an experiment. The data engineer does not have to worry about data science because they know that their data scientists are going to take care of it. They just need to watch and make sure that there are enough clusters, enough compute power, and enough memory and storage to actually support the experiment. And then, of course, business doesn't need to know how the sausage is actually made. They just take a look at the end report at the end of all the work. So again, it supports collaborative workspace. I will show you how the notebooks look like later. Your data engineers, your data scientists, and your business analysts have very specific scopes that they can focus on and pass the work around without having to worry about how the other guy is doing his job. It allows you to deploy production jobs in workflows. So you can actually create multiple experiments and then string them to data or events, hook them up to events, so that if a certain event occurs or if a certain trigger is fired up, automatically data will flow into the notebook, and the output is actually passed on either to another experiment, another application, or some form of storage, whether blob, data lake, or database for structured or unstructured data. It also supports multiple runtime engines. So as I mentioned earlier, it already supports Apache Spark, but it also can leverage serverless technology if you need to run custom code. It can make REST API calls, and it's capable of accessing Databricks I/O capabilities. Collaborative workspace, the easiest way to actually show you is to show you how a notebook looks like. So this is meant to be a demo for the end, but because I'm running out of time, I'm going to jump into the demo immediately. So this use case is called anomaly detection. Is anybody here familiar with anomaly detection? So anomaly detection is actually effective. It's actually utilized in a lot of industries. So it can be in manufacturing, it can be in banking, it can be in media. It just takes different names, different forms, but they're all anomaly detection. So anomaly detection would be, for example, if you're maintaining equipment, if you're maintaining elevators, for example, you can put sensors across your elevator and monitor the amount of vibration different parts have in reference to the operation of the elevator. And over time, as wear and tear starts to go into your equipment, these vibrations start to vary. The characteristics of the vibrations start to change. And these anomalies can be detected and can be assigned that the elevator is up for maintenance. In the field of banking, if you're seeing a lot of fund transfers across accounts, anomaly detection can help you detect fraud, because the assumption here is that there is normalcy in the flow of transactions, and if suddenly there is a frequent kick-in of small transactions, or if there's a significantly large amounts of transactions happening unexpectedly or outside of the normal patterns, then these are things that should be investigated further. Healthcare, same thing. If you're monitoring the vitals of a person and the vitals of the person start changing, increased heart rate, increased alcohol level in the blood, or whatever vitals you're actually looking at, then these are actually signs that something is wrong with this person, and it warrants further investigation. So let's take a look at the notebooks. Okay. This is typically how your data scientists would be interacting with Databricks. Most data scientists, most experienced data scientists are already familiar with Jupyter Notebooks. It's actually an extension of Jupyter Notebooks. So what's cool about Jupyter Notebooks is that you don't only put code into the notebook, you can also put annotations. So it will contain your comments, your observations, additional information, aside from the code itself. So if you take a look at this, it is composed of both HTML-based annotations and actual source codes. And later on, as we execute them, also results. So let's go through this one. So we begin by setting up the environment for experimentation. And what we're going to use is we're going to use a hypothetical time series dataset. So after executing the hypothetical dataset, we decided to print a graph of this particular dataset. And this is how it looks like if you graph it. So if you take a look at it, it might be easy for you to say, oh, this particular graph has anomalies, right? But how do you quantify the anomalies? How do you identify? Just my time's up. How many anomalies can you actually identify from this? You need to be able to precisely identify those. So we modified the code a little bit. and we highlight those anomalies. Okay. So we put red dots on what we find are anomalies, or extremely high values of vibration. So here are your anomalies. Okay. So if this was an elevator vibration sensor, the more red dots I see, the more likely that this elevator is going to crash really soon and I need to perform maintenance, right? Okay. But there is a challenge to this approach. The challenge to this approach is, what if the data has certain seasonalities? So what if certain days or certain days of the week, certain hours of the day, the amount of vibration naturally happens. So it's actually harder to detect these types of anomalies. So you can quickly modify your code. So in this case, what I do is I compute the mean of the data, and then use that as reference to the rest of the data set, and then I graph it again. Okay. And I know that this is my threshold, and if I introduce the seasonalities, so I'm going to introduce a weekly cycle, assign as as the source of the variation. It would now be more difficult in this graph, as you can see. It would be more difficult now to identify which ones are the anomalies. So again, we compute for the means and try to normalize the data. And so we're able to establish the trend and still be able to come up with what we think are anomalous values. So it doesn't matter what kind of trend you're seeing on the data, whether it's linear, it's in the waveform. It will learn from the behavior of the data, what it perceives as the normal behavior of your data, and then identify for you what goes beyond that normal pattern. Now, if we take a look at the code that we wrote, okay, you'll notice that the code, if you're not familiar with Python, I would understand that it looks a little bit intimidating. But if you're familiar with Python and if you're familiar with Spark, you will know that most of the code I'm writing is actually labeling the graph. Because most of the algorithms that I'm actually using are coming from existing libraries that are available in open source today. Like what my colleague Rita earlier said, over the last 5 to 10 years, there's really not a lot of new algorithms that has come out. So you're bound to find an appropriate algorithm for the kind of problem that you're trying to solve. Now, again, one of the things that we'd like to highlight is that aside from being able to run the experiments across a cluster that you don't have to worry about how to set up, it also allows for collaboration, because what I can do now is I can take a look at this notebook, and I can generate new tokens so that people can applications can authenticate against them. I can invite other users into this notebook. So, like for example, my colleague Mike can take a look at my work and critique it and tell me if I'm skipping a procedure or if there is something wrong with my approach. People can give me comments on how I can further improve my model. So it makes my work subject to governance and review. It's very conducive to working in a team. Aside from that, Databricks also allows users to define what other people they collaborate with can modify. So you can say that person A can modify my notebook, but he cannot modify the infrastructure. Or people from group X can only modify the cluster but cannot play around with the actual data or the experiments. So it has a very high level of granularity, which again lends a lot of support to the governance in an organization.